if sin x is equals to 1 by 4, find sin x by 2, cos x by 2 and tan x by 2. We're also given that x is in the second quadrant. So pause the video, try this on your own. Okay, let's do this together. Now there are many ways of solving this. One approach could be to form a triangle, get the values of cos and tan from this sine. Be careful that x is in the second quadrant, so cos and tan will be negative. Once you have sine, cos and tan of x, you can pick your favorite ratio and get the values for x by 2. I'll use a different approach. I'll use a different formula, a little uncommon formula for sin x. I'll directly get the value of tan x by 2 from sin x. This is the formula that I'll use. Sin 2 theta is equals to 2 tan theta by 1 plus tan square theta. I'll plug in sin x and I'll get tan x by 2. This will form a quadratic. Once I have tan x by 2, I'll form a triangle to get sin x by 2 and cos x by 2. Now if you want to give this approach a try, pause the video, do this using this formula. Okay, let's do this together. So if sin x is equal to 2 tan x by 2 by 1 plus tan square x by 2, we can say that 1 by 4, because sin x is 1 by 4, 1 by 4 is equals to 2 tan x by 2. Let's assume this is a variable y. So that becomes 2y by 1 plus y square. Now this becomes a quadratic in y. If we rearrange, we get 1 plus y square is equals to 8y. Moving things around, we get y square minus 8y plus 1 equals to 0. Let's solve this quadratic. Discriminant will be b square minus 4ac. That's 64 minus 4. That's 60. So root d will be root of 60. That's 4 times 15. So that's 2 root 15. So root d equals to 2 root 15, which means y is equals to minus b, which is 8 plus minus 2 root 15 divided by 2. Let's cancel this 2. Y is equals to 4 plus minus root 15. Now here we're getting two values of y, which means we're getting two values for tan x by 2. Which one should we pick? Should we pick 4 plus root 15 or 4 minus root 15? So which one should we pick? Is our tan x by 2 4 plus root 15 or is it 4 minus root 15? Let's consider both the cases. If this is the case, this value is more than 1. And if this is the case, this value is less than 1. Tan is more than 1. This means our input is more than pi by 4. And tan is less than 1. This means our input is less than pi by 4. We can say this because if x is in the second quadrant, then half of it is in the first quadrant. So x by 2 is greater than pi by 4 here and x by 2 is less than pi by 4 here. Tan of pi by 4 is 1. So if we input anything more than that, we get more than 1. And if we put anything less than that, we'll get tan less than 1. Doubling this will tell us where our x is. So doubling this will give x as greater than pi by 2. If half of it is more than pi by 4, then x is greater than pi by 2. And here half of it is less than pi by 4, which means x is less than pi by 2. This gives us x in the second quadrant. This gives us x is in the first quadrant. So which one is it? Well, we're given in the question that x is in the second quadrant. So we rule this one out. We know that our tan x by 2 is actually. So this is our tan. Now we need to figure out sine and cos. And for that, we can form a right angle triangle. Let's assume this angle is x by 2. If tan is 4 plus root 15, this means perpendicular by base is 4 plus root 15. So 4 plus root 15 is our perpendicular and 1 is our base. Let's assume that the hypotenuse is z. Once we have z, we can figure out sine and cos. So let's do that. Z square equals to 4 plus root 15 square plus 1 square. This gives us z square equals to 16 plus 15 plus 2 times 4, 8 root 15 plus 1. So this is 16 plus 16, 32 plus 8 root 15. We can take 8 common. Z square equals to 8 times 4 plus root 15. So this is our z. We can take the square root. Root of 8 is 2 root 2 and root of 4 plus root 15 is root of 4 plus root 15. So that's our hypotenuse. Using this, we can find the values of sine and cos. Sine of x by 2 is equal to perpendicular by hypotenuse. That's 4 plus root 15 by 2 root 2 square root of 4 plus root 15. And cos of x by 2, that's base by hypotenuse. That's 1 upon 2 root 2 square root of 4 plus root 15. Now we can simplify these values. Let's look at sine x by 2. In the numerator we have 4 plus root 15. In the denominator we have square root of 4 plus root 15. So root cancels out and the numerator becomes root of 4 plus root 15 and the denominator is 2 root 2. We can even get rid of this denominator. We can multiply numerator and denominator by root 2. We have 8 plus 2 root 15 square root of this divided by 4. Let's do the same thing with cos x by 2. Let's rationalize the denominator. We can multiply numerator and denominator by 4 minus root 15 square root of that. So numerator will be square root of 4 minus root 15 and denominator will be square root of 4 minus square root of root 15 multiplied give us 16 minus 15, that's 1. So that entire thing is 1 and we're left with just 2 root 2. Multiplying both numerator and denominator by root 2, we can get rid of this root 2 here. So this becomes 8 minus 2 root 2 divided by 4. So this is our cos x by 2, sin x by 2 and tan x by 2.